Hello. This presentation summarises the results from a research project and report on agricultural methane in Irish climate action by me, Paul Price, undertaken as part of the Legacy for Life project managed by An Taisce and funded through the EULIFE programme for the environment and climate action. Analysis globally and for Ireland from the IPCC and by Ireland's Climate Change Advisory Council shows that early, deep and sustained emissions reductions are crucial to meet agreed climate goals. 95% of Ireland's emissions of methane, the potent greenhouse gas, are emitted from livestock agriculture, mostly from grass-based cattle and sheep farming. Agricultural policy since 2010 targeted to increase dairy production following the removal of the EU milk quota. This has driven a very concerning 61% increase in dairy methane since 2010, greatly in excess of minor total reductions from efficiencies and small reductions in methane from beef cattle and from sheep. In this report's analysis, the additional global warming since 2010 caused by Irish dairy methane equates to the warming that would result from emitting 1.4 billion tonnes of CO2. Unlike CO2, this warming impact could be greatly reduced if annual agri-methane emissions are reduced substantially. This report makes clear that adopting precautionary limits on milk and meat production would support coherent climate and pollution policy. First, I will show charts from this research that set out the recent context for agricultural emissions. Here we see charts of the relative change in emissions of methane on the left and nitrous oxide on the right for the period 1990 up to 2021, comparing the trajectory for Ireland with the EU average. In the EU, emissions of both gases first dropped sharply, then steadily, and since 2010 have levelled out at a level 20% lower than in 1990. In contrast, Ireland's emissions first rose and then dropped, but have risen sharply again since 2011 to be considerably higher now than in 1990. These increases in total emissions confirm mitigation policy failure in Ireland's agricultural sector. This chart for the period 1990 to 2022 shows the change in Irish dairy metrics for milk production, methane emissions, nitrogen excretion and dairy cow numbers relative to 2005, the EU reference year for national emissions. Since 2010, milk production has risen quickly to reach 77% above the 2005 value, resulting in total methane emissions increasing by 66%. Methane and nitrogen excretion have risen faster than cow numbers because the cows have been bred to yield greater quantities of milk per head, and that results in greater quantities of methane and nitrogen excretion as well. Efficiency gains have had little effect, and dairy increases have not been offset by beef or sheep decreases. Therefore, as experts warned prior to its instigation, the policy to expand grass-based livestock production for milk and meat product export has been incoherent with meeting climate and nitrogen pollution limits. Here, a simple analysis of United Nations Annex 1 emissions and milk production data indicates that Ireland and New Zealand have relatively high methane emissions per kilogram of milk produced, compared to the lower EU average, for example. A key part of this project was to clarify the use and potential misuse of two greenhouse gas equivalence metrics in emissions accounting. The standard one, the Global Warming Potential 100, GWP 100, versus the newer GWP star, a metric that has been particularly supported by livestock interests as a replacement for GWP 100. The crucial point is that GWP 100 and GWP star provide very different information. GWP 100 is a good gauge of total annual emissions and is embedded in accounting, so there is no good reason to change from it, whereas GWP star provides a useful supplemental method to gauge the change in warming effect over a period. This is important for methane because the warming impact of methane depends on changes in its annual emissions over time. The next two slides use GWP star for warming analysis of emissions since 1990. This analysis shows the total warming from EU member states due to their agricultural methane emissions. Remarkably, Ireland, equal with Spain, is responsible for the largest amount of warming due to agricultural methane since 1990. In many states where methane emissions have gone down, including large milk and livestock producers like Germany and France, total warming from agri-methane has actually reduced since 1990. This analysis shows the total amount of global warming resulting from each of the Irish emission sectors due to the combined emissions of all three of the key greenhouse gases, carbon dioxide in grey, nitrous oxide in orange and methane in blue. Agriculture has contributed by far the highest total global warming and, combined with other analysis, is shown to be the sector most responsible for Ireland failing to meet its EU and national climate commitments. In short, Ireland's agricultural climate mitigation has been a failure, especially since 2010. In large part, this has been due to policy favouring the growth of animal agriculture for food product export and the prioritisation of efficiency measures by the Agricultural Advisory Teagasc and the Department of Agriculture. Such measures do not equate to cutting total emissions, which is what is necessary unless production is limited or falling. Therefore, in this research, I applied a precautionary approach to quantifying animal numbers relative to meeting Ireland's 2030 emissions goals. Projected EPA emission factors are assumed for the animal types, including dairy cows. The analysis also assumes the proportions of animal type numbers shown by Teagasc's economic analysis for 2030. Emissions of CO2 and nitrous oxide are then assumed to occur at the same rate as for methane. Scenarios with different levels of methane reduction were then tested for pass or fail against the sectoral emission ceiling for agriculture. This chart simply shows the 2030 projected per animal methane emission factors, meaning that the annual total methane emissions per animal from both enteric fermentation, from stomach digestion in cattle and sheep, and for manure management. Dairy cows have the highest value, almost 3 times the average beef animal and over 15 times that of a pig or sheep. Dairy cows' high and rising per animal methane emissions mean that limiting total cattle numbers or even dairy cow numbers is not a meaningful limit on emissions. Declining quota limits on total milk and meat production would be more appropriate for use in mitigation of emissions and for limiting water pollution by watershed. This slide summarises the analysis outcomes. It shows that only a scenario targeting a 40% reduction in methane is likely to meet Ireland's 2030 EU and carbon budget goals. This outcome aligns with the urgency of methane mitigation shown in a recent journal paper by Professor Barry McMullen-Mee and Dr. Aidan O'Doherty in separate Dublin City University research following the Advisory Council methodology used to assess Ireland's fair contribution to climate action under the Paris Agreement. This bar chart comparison for animal types summarises the relative change results of the 2030 quantification. For each animal type, total cattle, then dairy cows, then beef cattle, and so on, the grey bar shows the 2021 value as 100%, then an orange bar shows the 2030 change according to Teagasc modelling, and the blue bar shows the 2030 change in animal numbers using the precautionary methodology adopted in this research. The Teagasc 2030 values in EPA projection show a small percentage increase in dairy cow and poultry numbers and modest decreases in other types, most of all in suckler cows. By contrast, this research shows that substantial reductions are needed in numbers across all methane-producing animal types. Teagasc show 1.7 million dairy cows and 5.1 million beef cattle in 2030. This research shows dairy cow numbers falling back to 1 million and beef cattle dropping to 3.1 million by 2030. Within this scenario, any increase in numbers of one type would have to be balanced by a fall in numbers of other types based on their emission factors. Summarising the results of this research on agricultural methane in climate action, a 40% cut in agricultural methane emissions is likely needed to meet 2030 climate goals. This is far deeper than the 10% cut suggested by the Ag Climatise policy or the small delayed methane emission reductions estimated by Teagasc that may or may not result from unproven feed additive outcomes. This research shows that precautionary national quotas on milk and meat production in policy have worked in the past and would work in future to guide the agricultural sector to meet climate and water pollution goals with certainty. Most importantly, for Ireland's future national food security and for farming resilience against climate shocks, greatly reduced dependence on intensive animal agriculture and its import reliance on fertiliser and feed would actually enable Ireland to produce more food. This can be achieved by adopting far less wasteful practices, especially through local nitrogen cycling that reconnects livestock with cropping systems within national climate goals and watershed pollution limits. The full Legacy for Life report on agricultural methane in Irish climate action is available from the Legacy for Life section of the An Taisce website, or you can download the PDF directly from the link shown here.